All right, welcome back. Okay, so we were looking at how this idea of this pointer was going to come into play in something like the set hour function. And so the set hour function was also going to be um, returning the time object by reference. So the return statement there was going to be return star this. And we also saw how you can refer to the this pointer directly by name right inside of the function with either the arrow operator or the star and the dot together. And we also talked about the type of the this pointer, which would be time star const in the set hour function. And so for the get hour function, we can also think about what it's going to look like there. So in a function like get hour, the type of this pointer is going to be time star const, because now we're making all aspects of the pointer variable constant. So we still have the const here after the star, like we did with the set hour, because the pointer is always going to be constant, right? We can't change it to have it point at something else other than the current object. And also, now the data is treated as constant as well, meaning what the pointer is pointing at is also constant, right? Which is why we can't change any of the member variables inside of the constant function, right? So this is for functions that are constant, like the get type functions. So if we try and say, this arrow hour equals a new value, or hour equals a new value, those are not allowed, right? And that's reflected in the type of the hidden this pointer and the get hour function. So now both of them are constant. So a little bit of a difference in the type, right, compared when we look at the get hour versus set hour function. So in the set hour, again, it's time. The type was time star const, but for the get hour function, it's const time star const, right? So the word const shows up in two different places. One of them being before the time, the other being after the star, because we're making both aspects of the pointer constant in this case. And then, like before, we can also refer to this pointer by name explicitly here. So instead of saying like return hour, we can also do return this arrow hour, or the equivalent return parentheses star this dot hour. So those can also be done in a get type function as well. And now we're also have been trying to think about how this is going to work in terms of the the cascading. And so we looked at, and we'll look at the complete code example here in a moment, but we're just kind of looking at part of this here. But the idea was that for the first set hour function, the return type was time ampersand. So the statement there at the end was return star this. Now we'll also look at the case of, well, what if the function is going to return a pointer instead of a reference, right? So meaning if it's going to have return type time star instead of time ampersand. That's going to be very similar overall, but there will be a difference in the return statement if we're going to have the return type time star rather than time ampersand, because in that case we'll be returning the address of the object rather than a reference to the object. Yes, you don't set it. Yeah, you don't set it directly because it's something that, yeah, the compiler automatically essentially puts in there for you. So it's just going to look at whether the function is constant or not, and that determines the full type of the this pointer. So in a non-constant function, in this case for the time class, it's going to be time star const. And then for a constant function in the time class, it'll be const time star const. And yes, that's done automatically. Yeah, that's a good question. And so let's look at the pointer example. So return type now is time star. This will be set hour 2. Parameter list is the same as the other set hour, right? So the type here is still going to be time star const. But the difference now is in terms of the return type, right? So the difference now is if we're returning time star, we know that this pointer points at the current object. And so in the one that had return type time ampersand, notice that we said return star, right? We said return star this. So dereference the current object and then return that. And now we want to do somewhat of a similar thing, but now it's the address that we need to return. So take a moment and think about, well, based on what we did here, when the return type was time ampersand, what could we do here for set hour 2 is the return statement, right? So what can we return for set hour 2 to make this work correctly based on the fact that the return type is time star? So in other words, based on what we did before, we can think about, well, what would have to change here for this version, for this one's going to be called set hour 2. What's going to have to change here since the return type is now time star instead of time ampersand? Okay, okay. Do we just return the, yeah, good. And we can think, yeah, we can also think about why that would perhaps work here. So return this without the star, okay. Yeah, we can look at that. So the idea was that in the other function, we did say return star this, right, where the star meant dereferencing the hidden this pointer. And that was going to work for the first set hour function up here, since it follows that if this pointer stores the address of the current object, if we dereference it, then we're going to get the object itself. And then since we said time ampersand, that means we're going to return it by reference. So that works for the first one. Only difference here is now we're changing what we want to return. Now we do want a memory address. So we're just going to return to this pointer, right? Because this stores a memory address. So we're just going to not dereference the pointer in this case. And that would be really the major difference between the two different versions of set hour. One returns reference, the other returns the address of the current time object. And that's really the only difference there. And of course, everything that we said, regarding using the keyword explicitly in the first set hour function, right? That applies here as well. So, again, we can do things like this arrow hour equals hour, this parenthesis star, this dot hour equals hour, and so on and so forth, right? That, of course, also applies here as well inside of set hour 2. But the major difference, right, but a very important difference is the fact that we have to return just this rather than star this. So very key difference there. So yeah, just return this. And then putting it all together, now we're able to do the chaining or the cascading. So now at this point, we've looked at the this pointer, we've looked at the type of the this pointer and how the type of the this pointer is different between non-constant and constant functions in the class, right? So with a non-constant in the time class, it'd be time star const. With a constant function, it'd be const time star const. And then we saw that the first parameter that's always passed, that hidden parameter, is the address of the current object. And because of that, we also saw how you can now do things like use the same exact name for the parameter variable as you did for the member variable. So that's another nice thing that comes up here, is now we don't have to always come up with a different name for the parameter variables, right? Like we did with all the previous examples. So now, if we're gonna refer to this pointer explicitly by name, then you can really always, use the same names instead of having to come up with different names like H, M, and S, right, and so forth. So that's another good thing about using the this pointer explicitly as well. Okay, so now we can put all that together and look at an example of this in terms of code. But that was the high level idea, right? Is that we wanted to be able to chain these function calls together. And then we also mentioned earlier And the initializer list a little bit different. In that case, you can just refer to the name of the variable directly because there's no issue of ambiguity in the member initializer list because that's sort of a special case because the syntax is always that the thing before the curly brackets is the name of the member variable. And then whatever is in the curly brackets is the value, which could be the name of the parameter variable. So in that sense, um, in the case of the member initializer list, we actually can do things like our curly bracket our, right? Just like that. So in the initializer list is a little bit different compared to what we're doing here in these member functions. Yes, yes. So they can have the same name, yes, in the constructor as well. But it's just, yeah, in the member initializer list, you can just do like hour, curly bracket, hour, minute, curly bracket, minute, second, curly bracket, second. And let me. Go ahead and pull up the cascading example here. Okay. Okay, so what we have here are two versions of several of these functions. So we have the four functions, which we've seen before: set time, set hour, set minute, set second. Versions that all return a reference, and then versions down here that all return pointers. And the rest of it is the same as what we've seen in some of the previous examples of the time class. And then so here in the time CPP, we start to see this idea of the cascading. So for example, in the set time, return star this. Set time 2 has the pointer, so just return this. Set hour, that one has return type time ampersand, so return star this. And then again, here we also use the same name for both the member and the parameter. And so here, when we want to set the hour, we can also do it with either of these two ways, right? Using the arrow or the star and the dot notation. So here we're technically doing it twice just to kind of show the point, but we know that those two are the same. And then we have set hour 2, which is very similar to the previous set hour, except it returns the pointer type, so return this. And then similar idea with the different versions of set minute, right, and set second. So we just did two versions of each of those set functions, where one returns a reference and then the other returns a pointer or an address. And then here we just had, similar to what we kind of wrote out in the Word document, we have some examples of what this chaining is going to look like. So here we first created time object T, and then we chained these calls to the set functions. And then we, after doing that, we just print everything out, right, using the universal time and standard time, just to confirm that everything's in there correctly for us. And then we called set time here as well with two standard string. And then here we had a pointer. So time PTR is a pointer of type time star, and then it points at T. And then we also changed some calls to the functions, in this case, the second version of the three functions. So we changed it with, we chained it with the arrow operators, right? Because again, that's a little bit more convenient than the longer star and dot together. And then we print them out down here as well with some calls to the two universal and two standard. And then again, we set it one more time and then print it out down here. And then we get all the outputs there. So just the various time values. So we're seeing that we're getting all the expected values there, right? And all the different chains that we have, right? So we chained it in some cases with the dot operator when we were working with references, and then we chained it with the arrow when we're working with pointers. So we're just seeing that we're getting the expected output there. And then we also saw a couple cases here too where we had things other than the set functions involved in the chain. So for example, up here we said t dot set time, which we know that that returns a reference to t, which was then used to call toStandardString. So that's fine because toStandardString is at the end of the chain. And then we did that down here in a similar way as well with the pointer, where toStandardString was also at the end of the chain here. So we can have, and again, those were not functions, right, that were returning the class object. But as long as it's, just at the end of the chain, then that's fine as well. So we saw that type of function being involved in the chaining or the cascading here as well. And so, the fundamental idea here is we are doing the function calls one by one. So we just have to keep in mind that in the beginning, we start out with an expression like this, but then since the function call is returning a reference to t itself, t dot set hour, right? The idea is that in effect, right, it returns t itself, which is then used to call set minute, right? So and of course, and it's a very similar thing for the ones where we chained it with pointers, right? Same idea, but with pointers and addresses instead of references. So same general idea, right, in terms of what happens when you're chaining with the arrow operator, right? So this just reduces into a smaller and smaller expression until you finally call, right, the last function in the chain. Okay, so that's the idea with this pointer, and then how that ties in with this idea of things like cascading function calls. So now that's going to allow us to do that. And again, these are things that we'll also see come up in chapter 10 when we talk about operator overloading. Is this idea of chaining or cascading, right, is also very important there, because in general, you want to be able to chain operators on the same line, in the same expression together on the same line of code. And so to do that, right, we have to think about these issues like cascaded, cascaded member function calls in the context of operator overloading. So we'll certainly see that come up again in chapter 10. And so last thing that we'll look at here in chapter 9 is the idea of applying the keyword static to either a member variable or a member function. Now, we know, because we talked very early on in chapter 3 about what is stored in memory, for an object. And we said that for each object, right, you have to store all the member variables, because that's how we're able to store different values for things like hour, minute, and second for all the different time objects that we might have, right? For example, in the application program. But we also said that there's only one copy of the member functions, right? Because they are, because they're shared. But sometimes we have data in a class that we might need to only have one copy of. So meaning things like hour, minute, and second, right? We do have to have those individually for each object, right? Otherwise, of course, there would be no way to maintain 100 different time objects simultaneously. But sometimes you have certain types of data values that you really only need to have one copy of, right? And that one copy is going to be used by all of the objects or shared by all of the objects. And that takes us to the idea of static, which you've used static in other ways before, but we're talking here about using static in the context of members, right, of a class, meaning member variables or member functions. And so the idea really is that when we have a member variable that's static, then we call it global to the class, right? So a static member, for example, a static member variable is global to the class, meaning there's one copy of it and that's it, right? So it's, in that sense, it's shared across all of the different objects that might exist in the class and in the class. And now we still want to think about how the access specifiers, would factor in here. Because we've been following this rule where the member variables have basically always been private, right? We haven't really ever made them public because we've been doing things in terms of functions, right? Whenever we want to work with or change the member variables. And that should still continue to be the case, right? Even when we're working with a static variable, which means that there will also be functions that we'll use to work with the static member variables that we have in the class. And those functions will also be declared static, right? So you have static variables, and then you have static functions that can work on those static variables. And in fact, we'll actually see that when you have a static member variable, both non-static functions and static functions can both access those static variables. and as we'll see in the example we'll look at, right, it's important that that's the case, because certainly we might need to be able to change, the value of a static member variable inside of a non-static function. Because one of the things that we're going to look at is an example where we're going to have a static member variable to keep track of the number of objects of the class that we've created. So we only need one copy of it, which is why it's static, right? Because we're going to have one thing that stores the total number of objects that currently exist. And we're going to need to be able to change that static member, right, in non-static member functions. In particular, we're going to be changing it in places like the constructor and the destructor, right? Because the idea is that, of course, whenever you invoke the constructor, you've just created a new object, right? So when the constructor finishes running, the object has now been initialized. So you would need to increment the value of the static member variable, assuming that's its purpose, right, is to keep track of the number of objects. Then you would need to increment it inside of any constructor that you might have. And then also on the destructor side, we know that a class has one destructor. But since it's keeping track of the number of objects that currently exist, and we know that objects can have different scope levels, and then objects are destroyed, right, when they go out of scope. So at any point in time, right, potentially an object could go out of scope and be destroyed, in which case we would need to decrement the value of the static variable that's keeping track of the number of objects that currently exist. And of course, as constructors and destructors are non-static functions, so they need to be able to access the static members. So the whole idea is that a static member function has, a specific purpose, right? Its purpose is to work on or do something with a corresponding static member variable. So one of the things that we're going to see is that a static member function cannot access or modify the non-static member variables of the class. So for example, in the case of the time class, if we had a static function, right, we would not be able to do things like refer to the hour or the minute or the second, or try to change it inside of a static member function. So static member functions can only access static member variables, but not non-static member variables. But a non-static member function, which would include things like, right, your constructor and destructor, non-static member functions can access both types, right? Meaning, of course, they can access non-static member variables, which we've been doing all along, and they can also access the static variables too. Because in general, a static variable is something that we might need to access in both types of functions, right? Non-static functions and in static functions. But inside of a static function, there should never be any reason why you're trying to access a non-static member variable. And so the whole idea is that inside of a static function, there is no this pointer, because there is also no concept of the current object. Remember, a static variable does not belong to an object, right? There's one version of it. There's one copy of it. So we don't need anything like the this pointer, because that whole idea doesn't really apply inside of a static member function. So what you can do in a static function is you can access or change your static member variables, and that's it. So there is no this pointer, right, in a static member function. And for similar reasons, right, a static member function can also not be declared const. And we can think about why that is. but it really comes down to, well, what is the meaning of const in terms of member functions? Well, so we know that, you know, const has always been used up to this point for functions that never, you know, the value doesn't change.